If you were good at an SN1 and SN2 reaction, you're probably good at E1 and E2 because they follow the same trend. All right. We talk about overall reaction, then go to talk about mechanism, and then what factors affect the mechanism. Talk about the red law. What else? The energy diagram. It just goes with the same trend here. If you still remember, in SN2, the primary alkyl halide is the best substrate for an SN2 reaction. It allows backside attack, and tertiary block backside attack completely. Remember that? So the fastest one and the slowest one for an SN2, SN1's reverse. For an E2, it goes like an SN1. Now, it's similar to an SN1, but for different reason. And here's the reason why. This guy goes the fastest, more substitute on alkyl halide, right? The highest substituent. How come though? Let's say I'll take primary, secondary, tertiary alkyl halides. All of them do elimination. Okay, so beta elimination is E2. Pass through this transition state and go all the way to an alkene. All right. So this guy goes the fastest, which means that the activation energy is the lowest. Right? The activation energy of the lowest. So this guy's stable, right? Which means this transition state is stable. The more substituents, the more stable alkene, if you still remember that, right? So this alkene is the most stable. The transition state is the most stable. So the lowest activation energy and the reaction goes the fastest. If you're not sure what I'm just talked about, let's take a look right here. Look at the energy diagram, right? If I plot the energy diagram, the tertiary alkyl halide, when it's about to become alkene, if this guy were to be an alkene, double bond right here, this guy are disub, that disubstitute alkene, compared to monosub, compared to unsubstitute alkene. So the more substituent on alkene, the more stable, if you remember that. So the lowest activation energy, and the reaction go the fastest one. Okay, so tertiary is the best substrate for an E2, followed by secondary, followed by primary alkyl halide. All right, so fastest rate right there. This doesn't mean that primary goes slow. They could go fast. Depends on the condition that you use. If you use strong base, can facilitate the reaction as well, right? But the tertiary is faster than secondary and primary, right? All right, rank real quick. So if I take all these alkyl halide, do an E2 reactions, who goes the fastest? Oh my God, this is simple. So tertiary, we got secondary, we got primary, totally A, B, and C. That trend. All right. If you don't know the reason, all right, I'm going to show you the E2 reaction. So on E2, you should get double bond right there. This is 1, 2, and 3. This is trisub alkene. If you do it in E2 on B, you should get a disub alkene, disubstitute alkene. And if you do an E2 on a C, you should get also disub, but exo. All right. The stability of this alkene ranked by the most stable, second most stable, and the least stable. So the transition state for this guy gonna be the most stable one. All right. So A faster than B is faster than C. Okay. All right. Let's draw the reaction mechanism together right here in the product on the next video. All right.